Hello and welcome to another video brought to you by RouTube. In this video, I will explore all things box plots. Students are introduced to box plots in Year 10 in their statistics unit and will continue to develop their understanding up until Year 12 for the maths. Okay, so we've got 5 learning objectives for this video. The first one is to understand that a box plot can be used to represent the 5-figure summary of a data set. The second objective is to understand that the sections of a box plot each represent approximately 25% of the data. The third one is to be able to construct a box plot or box plots using the CAS. The second last one is to understand that parallel box plots can be used to compare 2 or more data sets. And finally, the final objective for the video is to be able to construct parallel box plots using the CAS calculator. Okay, so box plots. So what are they? So a box plot, which is often referred to as a box and whisker plot, is a graphical representation of the 5-figure summary, which is often referred to as the 5-number summary. Okay, so if you're not too sure about the 5-number summary, they are listed at the bottom here. So the first one is minimum, second one is Q1, the third one is the median, which can also be referred to as Q2, the fourth is Q3, and the fifth is the maximum value. Okay, so that's the 5-figure summary or the 5-number summary. So in a box plot, the box is used to represent the middle 50% of scores in the data set. So you'll see we have our box, which I will just color in yellow. So this yellow portion that I've just colored in, that represents 50% of the scores in the data set. The median is shown by a line drawn within the box, which we can clearly see here in orange. Okay, so the median, now it's important, the median won't always be in the same spot. Obviously it depends on your data. So it might be smack bang right in the middle of the box. It might be to the right, to the left. And that's when we talk about skewness, which we won't sort of talk about at the moment. But it's important to understand that the median will definitely move from question to question. And then we have whiskers, which are just lines that extend from the upper and lower ends of the box to the smallest and largest data values in the data set. Okay, so we've got these green whiskers on either end. Now, sometimes they're the same length, sometimes they are different length. Most of the time they'll be different length, and sometimes some box plots won't even have a whisker. Okay, now it's really important, and I'll just highlight it in yellow, this little statement here. Okay, so let's read that again. So the whiskers extend from the upper and lower ends of the box to the smallest and largest data values in the data set, okay, except for outliers. Now, if you're not too sure on outliers, don't worry, because I'm going to cover them quite shortly, but it's important to know that the whiskers do not extend to the outliers. The whiskers extend to the maximum value that is not an outlier and the minimum value that's not considered an outlier, okay? And in a little bit, we're going to sort of go through how to calculate outliers and get a better visual representation of outliers on a box plot. So the key features, we've pretty much gone through them all. All right, so we've got our box, which is in yellow. We've got our median, which is in orange. We've got our whiskers, which are in green. And we know that a box plot is just a graphical representation of the 5-figure summary, which is the minimum, Q1, Q2, which is the median, Q3, which is the upper quartile, and then we have our maximum value. So Q1 and Q3 are referred to as the lower and upper quartiles, respectively. All right, now let's have a look at outliers and the upper and lower fences. Okay, so often you might look at a piece of data and you might say, oh, gee, there's a couple of values there that just don't belong with the rest of those values, okay? And often when you do look at those values, you might say, okay, they are outliers. Okay, so from this day forward, we don't ever guess to see if something is an outlier. Now or after this video, you will have a concrete way of calculating whether a specific data value is or is not an outlier. Okay, and the way we do that is by calculating the upper and lower fences. So first of all, an outlier in a data value is a data value that appears different to the other values in the data set. Sometimes it's difficult to decide whether a data value is an outlier. Okay, but like I said, from this day forward, you should be pretty confident in working out whether something is or is not an outlier. Determining imaginary fences, which we call the upper and lower fences, assist in identifying whether specific values are outliers. Okay, so to calculate what we call the upper fence, we need to find the value of Q3, which is our upper quartile. We need to add 1.5 and multiply by the interquartile range. Now, if you're not sure about interquartile range, I have created a video on finding the interquartile range. Now, it's important your CAS calculator can give you all of these values. I won't give you the interquartile range, but it'll give you Q3 and Q1, which will then you'll easily be able to identify or calculate the interquartile range. So it's essentially 1.5 times Q3. That's your upper fence. And the lower fence, pretty similar. Then we've then got Q1 and then minus 1.5 times IQR. So it's 1.5 times less than your lower quartile. So if we just jump down straight to the box plot, we've got our Q3, which I've just marked in yellow, and our Q1, which I've marked in yellow. And we can see that this yellow here, that's 1.5 of the IQR below Q1. And then we have our lower fence. And then on the other side, we've got our 1.5 times our interquartile range, which there draws our imaginary upper fence. So essentially what it means is that any value that is greater, any value greater than the upper fence is classified as an outlier. So any value to the right of the upper fence is what we call an outlier. And you'll see on the box plot below, we've got 3 outliers listed with the arrows, and they are drawn with either a cross or generally with a circle like you can see there. And then any value that is less than the lower fence is considered an outlier, which we can see 1 on the left-hand side. Now it's important that you know that you don't need to draw the fences when you draw a box plot, okay? You just calculate them and then explain or answer the question and justify whether there is or isn't an outlier in your data set. Okay, so these 2 dot points here that I've just highlighted in green are extremely important. Okay, as is all this information, but it's important to know that when you calculate an outlier, any value that is greater than the upper fence is considered an outlier. Any value that is less than the lower fence is considered an outlier. And we've got our formula to calculate the upper and lower fences. Again, you are not required to draw the fences on the box plot. Just find the value of the fences, and then any value greater than the upper fence, outlier. Any value lower than the lower fence is an outlier. All right, let's have a go at using the CAS to create or construct a box plot. So like most of your univariate data unit, you are going to begin by opening up and accessing the list and spreadsheet function on your calculator. Okay. Now, as always, whenever you input anything into this this page, this list and spreadsheets page, you need to give your column a title. Okay. Now, don't worry, you can call it whatever you like. I just called it score because that's what pops up every now and then. You can just call it X, Y, your name, anything you like, as long as you give it a title. So then we're going to enter in our data. Now, it doesn't matter which order you input your data, okay, because your calculator is smart enough to rearrange it and find everything for you, including the median, because we know if we do the median by hand, we need it in order. But for all stats stuff on the CAS, it can reorder it for you. Okay, now to create a box plot from here, we now go to our menu, and then we press on this pinky data and stats page here. Okay, now you'll see your pieces of data here, and then when you do, you need to click on the X variable, click to add variable on the X-axis, and you'll see you press your variable that you saved it as. Now, if you didn't give it a title, then it will obviously not pop up and you won't be able to do what we're about to do. Okay, so you need to make sure you give it a title. So we press score, and there we have our dot plot created. So if you wanted to know how to do a dot plot, that's how you do a dot plot. And then our final step to creating or constructing the box plot is to then hit menu, plot type, and then you'll see option number 2 is box plot, and you'll see live, it converts it to a box plot for you. And now we have a box plot drawn. We have our axes also drawn. So it's as simple as just copying this down from the calculator onto your page. Okay, so if we hover over any of these values, the 5-figure summary from the box plot, the actual values come up. So we know the start of the whisker, that is our minimum value. So our smallest value in the data set was 0. If we hover at the start of our box, which is Q1, which it says just there, Q1, so our lower quartile is 4. We've then got our box, our median is 5.5. We've then got our Q3, which is 9, and then what looks like our maximum value, which is 12. Okay, now a really common question, and what often gets a mistake happens is when they're asked for the maximum value of this data set, most students stop here because they think that the whisker stops at the maximum value, and it is correct, the whisker stops at the maximum value except for the outliers. Remember, we spoke about it at the start of the video. So the maximum value is actually this outlier here, which is drawn using a circle, like I spoke about previously. So when you're drawing your box plot, any value that is an outlier, which is this one here, the whisker doesn't go to that. Okay, so the whisker goes to the next highest value or next lowest value. That's not an outlier. So it's as simple as redrawing or drawing from your CAS onto your paper and then making a statement and answering the question accordingly. Okay, so now we turn our attention to parallel box plots. So parallel box plots are box plots, surprisingly, drawn on the same scale and can be used when there are 2 or more groups of numerical data. Okay, so we're dealing with numerical data and we have either 2 or more groups of numerical data, and therefore they are on the same scale. Okay, so that's a pretty good summary of parallel box plots. So parallel box plots can be used to compare multiple distributions, which we've spoken about already. When comparing distributions, always remember to comment on the following. Okay, obviously go by the question, but generally what you're asked is to compare the center, which we refer to as the median, which is Q2. We then have the spread, which is either the range or the interquartile range, mostly the interquartile range, and then possible outliers. Okay, so in the box plots below, we don't have any outliers, but in the ones previously, earlier in the video, we did see some outliers. So those are some things to make comment on, but of course, go with whatever the question is asking. So we have a look at this parallel box plot, and it's all about, or parallel box plots, and it's all about soccer goals scored for 2 teams. So we've got our axes labeled as soccer goals. We've got clear scale, okay, increasing by 5 each increment. Okay, so make sure there's an even distance between each value. And then, like I said, each box plot is labeled with team 1 and team 2, or whatever the case may be in the question. And then we've got our 5-figure summary clearly being able to be identified. Okay, and then of course we can then compare things like medians. So the median for team 1 was 21 compared to 19 for team 2. We can talk about interquartile ranges we've spoken about, and we can compare possible outliers if there were, which there are not in this parallel box plot. Okay, so now we're going to have a go at constructing parallel box plots. Okay, so we're ending from where we were before when we entered in the data and created our box plot. So what we need to do is we need to go back to our list and spreadsheet. So we go back to our previous tab and enter new data. So I'm just going to make this data up on the spot. Okay, I'm just going to call it score 1. Okay, I'm just going to make this data up on the spot. So we've got 8, 4, 5, 6, 1, 2, 3, 5, 11, and 17, just to make sure we have the same number of values. Okay, so now if we want to create a parallel box plots with both of these data, what do we do? Okay, so we go back to where we were, where we have our box plot drawn, and we know how to read that as we did previously. Now what we do is we then hit menu, and then we go to plot properties, and then we want to add another variable on the x-axis. Okay, so we then hit option number 5, which is add x variable, and then it will actually ask you, hey, which one would you like to add? So we've already added the score, which is our first piece of data. We would like to add score 1. And then as soon as that happens, magic happens. There you are. So as soon as you press that, it color coordinates them, it shows you your outliers, it draws your box plots, and it actually gives you a label for which one is which. Okay. Once again, and the most important thing, as we spoke about previously, is both of the box plots are on the same axis. Okay, actually, so now you are able to compare and make comparisons between the medians, between Q1, Q3, the ranges, the outliers, etc. Okay, so clearly in the second piece of data, we're given our box plot, and once again, we've got an outlier. So we could make comments the fact that both pieces of data have an outlier. We could compare ranges, like I said, we could compare interquartile ranges. We could compare medians. There's a whole host of things that we could compare with these parallel box plots, but they are the steps to create parallel box plots on the CAS calculator. Thanks so much for once again tuning in to another RouTube video. Hopefully you learned a thing or two about box plots and the CAS calculator. If you did learn a thing or two, or you're just feeling a bit generous, as always, please feel free to like and subscribe to RouTube, my YouTube channel, and I will catch you next video.